Hello everyone, in this video we're going to talk about some special factored forms and look at your top right hand corner. You will see six possible factoring forms that may be handy to you when you have to factor. Okay, so the first one is the difference of two squares, because you see there's a minus sign, so we're talking about a difference, and then both terms are squares, so it's a difference of two squares, and it is factored accordingly as listed on the right side of the equation. Okay, the second type is the sum of two squares. Okay, and it's called prime because we cannot factor it, right? It has to be left as it is. Now the third type has three terms and there's only a sum involved. Okay, we're only adding the three terms. Now as you see, there are squares seen on the left side of the equation. So you know that because there are squares and there are three terms, it can be possibly whatever polynomial that you need to factor. If you have three terms and there is a sum and there are squares involved, it most likely will be the square of a sum. And why is it a square? Because the sum of a plus b will be multiplied to itself, which is the same thing as saying a plus b squared. Okay? The fourth type will have a minus sign and a plus sign following it. Okay, so the second term will have a minus sign and the third term will have a plus sign, and there will also be squares involved. Okay, so that will push you to think that it might be factored as follows if you see a similar polynomial like of this form type, and it's called the square of a difference, right? Because you're taking a difference of a and b and you're squaring it, because a minus b is multiplied to itself, so it's the same thing as saying a minus b squared. The fifth type is the sum of two cubes. There are only two terms. Each term is cubed, raised to the third power. And that is factored as a plus b multiplied by a squared minus ab plus b squared. Okay? And the last type that might be handy to you is the difference of two cubes. And once again, only two terms, and you're subtracting one cube from the other. And that's factored as a minus b times a squared plus ab plus b squared. So let's start with an example. So if I give you an example like this, let's say 16x squared plus 4. Do you think it can be factored? Well, first of all, which ones are you going to use for this as a possibility? You're going to use only the one with the two terms, right? Because this polynomial has only two terms. So you obviously have a plus sign, so you're going to only deal with two terms with a plus sign involved, right? So it's going to be only the second type, right? It cannot be the next to last type because there are no cubes involved, right? Because there's x squared, so that should already tell you it's not going to be a cubed term. Okay, and think of the numbers too. The numbers are 16 and 4, and they're perfect squares each, right? So we can express them as 4 squared times x squared plus 2 squared. So we can combine the 4x together because they share the same power. So we can raise the product of 4x to the power of 2 plus 2 squared. And you can tell that there's nothing you can do with this. You can just leave it alone. There's no way to factor it. Okay, so yeah, it is a prime. So now let's see in the second example. What if we have something a little tougher? Let's say if we have 9 plus, oh sorry, looks like a G, sorry about that. Should have a 9. So let's see, 9 plus 48x plus 64x squared. Now, which type are you going to choose as a possibility to factor this, to see if you can factor it? Well, there are only pluses and there are three terms involved. okay? And there are squares pretty much, right? Because 9 is a perfect square, and you see an x squared for the third term, and 64 is a perfect square, right? And so three terms added together. So which one are you going to choose? You're going to choose out of these two the third one, right? Because there are pluses only, right? And it makes sense because you're dealing with the square of a sum. So let's see if we can use the square of a sum. But before we do that, we have to figure out a and b, right? So what is a going to be? So we're dealing with a squared plus 2ab plus b squared, right? So a squared is 9. So a must be equal to 3, right? So let's rewrite this as 3 squared. One second. 3 squared plus, so we have to have 2ab, right? So 2 times 3, because 3 was a, right? 2 times 3. Now 2 times 3 is 6. 6 times what gives you 48? Times 8, right? So we have to have times 8. And now we figured out the b, right? Because 8 is the b. Because a is 3 and 2 is part of the formula. So 8 must be the value of b. And it makes sense because b squared, b is 64x, right? The product of 64 and x is actually the b value. So we can express, we can just rewrite it before we simplify it completely as 8 squared x squared, right? And then we're going to have 3 squared plus 2 times 3 times 8x plus 8x. So let's combine it like that, 8x. And then 8x, since they share the same power, they can be expressed as a product 8x raised to the power of 2. Because they share the same power of 2, each of them, right? So now let's see if we can, now that we know what the a's are, so the a is equal to 3, b is equal to 8, 8x, actually not just a, but 8x. And so using this in the formula, we're going to factor it as a plus b times times itself, right? So it's going to be 3 plus 8x, right? And then multiply it to itself, 3 plus 8x. Okay? Now, if you try to use the FOIL method to check yourself, you will wind up with 3 squared and then plus 3 times 8x plus 3 times 8x, right? The middle two terms. And that should give you 2 times 3 times 8x, right? So it makes perfect sense. And then the last term gives you 8x times 8x, which makes perfect sense because here in the previous step we had 8x squared. So it's actually true. So your intuition hasn't failed you because you did deal with the square of a sum in this example. Let's try the next example, number 3. Let's try something like this. 27x to the third y to the third minus r to the third. So x, y, and r are variables. Now, which one are you going to pick? Which one does it look like the most out of these common factoring forms, special factoring forms? Well, it looks like the difference of two cubes, right? Because there are two terms, there's a minus sign. We know that it's not going to be squares because r is raised to the third power here. That's already it should tell you that it's not the difference of two squares, right? So it's a difference of two cubes. There are two terms, so it's the last one here, right? So let's try to figure out what our a's and b's are, right? So let's see. So let's express 27 because 27 is a perfect cube, luckily, right? So we can express it like this: 3 raised to the power of 3, right? Because 3 times 3 times 3 is 27. So x to the power of 3, y to the power of 3, minus r to the power of 3. And then we have, so since the first term has 3 and x and y raised to the power of 3, we can express the product of 3xy raised to the third power, right? It would not change the result. Minus r to the third. So what does that tell you? That tells you that a is equal to 3xy and b is equal to r. Okay? So now let's see if we can use this formula, if we can really arrive at this result that we just arrived at. Let's use the formula. Use it here. Let's say a is 3xy, so we have 3xy minus r, right? Because that accounts for a minus b. And then parentheses, what's a squared? A is 3xy, so squaring that will give you 9x squared y squared, 9x squared y squared, plus ab. What's ab? The product of ab is 3xyr, right? Plus 3xyr. And then the b squared is simply r squared, right? So plus r squared, close parentheses. So let's try to do mental work and see if we distribute this back using the FOIL method, that we will arrive at the correct conclusion here. So the first term will give you 27x to the third y to the third. So that's already true. Plus 9x squared y squared r. Minus 9x squared y squared r, because we're going to deal with that now. So we dealt with that. So these two cancel out, right? The ones that I just indicated. And then the next one will be this one, right? This pair. Minus 3xyr squared plus 3xyr squared, so that cancels out. And then the last term is this, minus r multiplied by r squared, and that gives you negative r to the third, and that's exactly what we have here, right? So we did arrive at the correct conclusion here. Okay, so it really is the difference of two cubes, as we had suspected before. So let's try the last one. Let's try something like 25y squared minus 40y plus 16. Which one does this look like? Well, we have a minus sign, we have alternating signs, right? Minus sign for the second term and a plus sign for the last term. And there are three terms, and it looks like we're going to be dealing with squares, right? Because 25 is a perfect square, 16 is a perfect square. So we're going to do, which one does it look like? It looks like this fourth one right here, right? Because there are squares involved, and there's a minus sign for the second term and a plus sign for the third term. So we should use a minus b times a minus b, right? And it is the square of the difference of a and b, okay? So, but let's find out what the a's and b's are. So let's rewrite them. Okay, so 5y raised to the power of 2, okay? And that will give you 25y squared, right? So a will be 5y, and then minus 2 in the formula 2, and then a is 5y. And what do you need to arrive at 40y? You need to have 10y multiplying by 4, right? 4. So 4 is the b value, which makes sense because b squared is 16, right? So plus 4 squared. So that gives you, so that should give you, using the formula, a minus b times a minus b. So let's see if it works. So a was 5y. And then the b value was 4, right? So 5y minus 4 must be multiplied to itself to produce the original polynomial that we started with, 25y squared minus 4y plus 16. But let's check if it does. So the first, using the FOIL method, we get 25y squared, right? Because 5y squaring the 5y gives you 25y squared. Minus 20y minus 20y, that gives you minus 40y, which is great, so it checks. And then the last term gives you positive 16, which also checks. Okay, so it is what we suspected originally. It is the difference, the square of a difference of a and b. Okay, the fourth line. So hope you enjoyed this video. I'll see you in my next video. We're going to talk about a different topic.